All right, the conclusion of Math 3, we'll just go over weight-dependent dosing. So weight-dependent dosing, there is only pretty much 4 steps. A, B, C, and D. And the last step you already know. So step A, B, and C, that's to get you to the order per dose. So the first thing you probably will need to do is take the pounds, divide by 2.2 to get you kgs. Right? Whatever answer you get in part A, you're going to use it as the beginning of part B. So you take their weight and you're going to multiply it by the order per kilogram. So here's the order per kilogram. So that's going to give you the daily dose. Right? So in a whole day. But sometimes we don't give you all the drug at once because it might kill you. So we spread it out. So we'll take that daily amount and we'll divide it amongst doses. So sometimes it's 2, 3, 4 doses. Now this is going to give you the per dose amount, and this is what we want. So steps A, B, and C, it's just to get you to here. And then in step D, we already covered. All we got to do is order over supply times the amount. Right? So step D, just do A, B, and C in order to get your order. All right, so for this example, the patient weighs 165 pounds. So in step A, you know the first thing you'll need to do is convert to kilos. Right? So all you got to do is divide by 2.2. So everybody, take out your calculators, punch in, watch your mouth, punch in. Take one pass it up. So punch in 165 divided by 2.2. What do you guys get? $75. Good. So that was step A. Step A, you got 75 kgs. So in step B, we take that 75 kgs, and how much is ordered per kg? 5 milligrams. So we multiply by the order. So how much drug do we need in a day? Yeah. Yeah, that's right. So the units are here. All the units are here if you're if you're keeping track. But I'm teaching you guys the shortcut. Right? So 375 per dose. So this is per dose, which is also in this case per day. So we don't have to do C at all. So this patient would need 375 milligrams per dose. All right, in this example, we're not going to give it to them all at once. We're going to divide it in 3 doses. So step A, what's step A? All right, so take 135, divide by 2.2, what do you get? 61.3. Okay, about 61.3, 61.4 is closer. 61.4 kgs. What is the order per kg? 25, right? 25 milligrams. So how much drug do you need per day? So take 61.4 times 25. $15.35? Okay. So in a day, they would need 1535 milligrams. But we're not going to give it to them all at once, right? No. We're going to give it to them in 3 divided doses. So we got to divide that 1535 by 3 doses. So you need, yep, about 511 milligrams per dose. And lastly, step D, if they gave you the supply, order over supply times the amount. So good. So you came out with 511. So let's see. They got the weight. You want to divide by 2.2, multiply by the order, right? 25, and then divide by the doses. Right? So if you're keeping track of the units, that's how they cancel out. And you're left with milligrams per dose. Yeah, so we got it. About 511. All right, ready for the challenge one? No. Well, it's ready for you. Okay. All right, so step A. What is step A? So do 215 lbs divided by 2.2. And that gives us a, how much? 90. Let's just do 98 to make it easy on ourselves. Right? All right, so we got 98 kgs. What is the order per kilogram? 10. So here it is, order per kilogram. So the patient will need 980 milligrams in a day. Or we're going to give it to them all at once? 3. No, right? We got to give it to them in 3 divided doses. So we'll take the 980 divided by 3 doses. What'd you get? 3. We'll round it. 327. All right, so that's how much they need per dose. Part D is order over supply times the amount. So we already know our order, and our supply is here. So our order is 327 milligrams. Our supply comes 1 gram, which is 1,000 milligrams per 20 of those. There you go. 210, it's about 100. 1,000, a third. How many mLs do they need per dose? So you got 6.6? About 6.6 mLs. Alright, so that's how you would do weight dependent dosing. A, weight into kgs. Once you get the kgs, you multiply by the daily amount. Or sorry, the kg, drug per kg. Then divide by doses. And then your last step, order and supply problem. So you'll see this as a DC sometime over the weekend. So don't worry about emailing me. Definitions, definitions, definitions. So today in lecture, we had NS in one of the doctor's orders. So by definition, that stands for normal saline, which is 0.9% sodium chloride. All right. So NS is not NaCl, right? Those two things are not the same. NS is 0.9% NaCl. Those two are the same. Right? So NaCl just means sodium chloride. Got the E. What is half of 0.9? Half of 0.9 is 0.45, right? So that is half NS. What is 1/4 of 0.9? So 0.9 divided by 4 is 0.22. So half normal, quarter normal. Gotta memorize those normal numbers. They will not give it to you. Anytime I say NS, you know, oh, 0.9%. If I say half NS, you know automatically, oh, 0.45%. Water, how much stuff is in water? There better be nothing, right? No drugs, no salt, no nothing, just water. So it's 0% stuff, 100% water, right? And then D in this case stands for dextrose. So the two most common IV solutions are D5 and NS. They are balanced with your blood and they will not damage your blood. Dextrose 10%, right? A little more concentrated. Dextrose 70%. You got to dilute it before you put it in their veins. Food, when we have to feed you through your veins. So if you can't get food through your GI tract, blockage or surgery, then we got to feed you through your veins. Put sugar through your veins. And then we got to use a little higher concentration. Make flashcards, get to know those definitions. All right, so that ends Math 3. We went over temperature conversion, order and supply in part 1, and then we just finished up this in part 2. Let's go on to the in-class homework. So week 3, day 1, we did Monday. Now let's do week 3, day 2.